Hello, my amazing math students. This is Mrs. A, and I love math. And today we're doing in our Saxon Orange book, lesson 70A, which is all about probability. And probability, the study of probability, is based on the study of outcomes that have an equal chance of occurring. So when we're talking about that, we're talking about things like flipping a fair coin, tossing a die that has 6 faces, choosing a random card from a deck of 52 cards. All of these are going to be experiments. We'll call each one of these an experiment, and each of the possible outcomes that could happen should be of equal probability. So we're going to have to figure out probability based on these things. In other words, if I toss a coin and it's a fair coin, we're going to always assume it's a fair coin, then the outcome could be tails or heads. And each one of those outcomes is going to have an equal chance of happening. Now, when we list all of the possible outcomes, we call that the sample space of the experiment. A die has 6 faces. So if I rolled a single fair die, many times, I should have about 1/6 of the rolls be a 1, and about 1/6 of the rolls be a 2, and about 1/6 of the rolls be a 3, and so forth. When I'm choosing a random card from a deck of 52 cards, that's the experiment. And since I have 52 cards and I'm randomly choosing one, then I have a probability of choosing a certain one. 1 out of 52 would be my probability of choosing an ace of clubs. Okay, so that's what probability is all about. So we're going to use these words: experiment, outcome, sample space, quite a bit. Okay, some more about probability. The probability of an event is the number of outcomes that satisfy a certain requirement divided by the total number of outcomes in the sample space. So, for example, if I were going to say I was going to roll a die and get an odd number, then I would think, okay, there are 3 odd numbers on the faces of a die: 1, 3, and 5. So I would have 3 odd faces out of 6 total faces. So 3 over 6, or 1/2, would be the probability that I would roll an odd number on a die. And your probability will always be between 0 and 1 inclusive. That means it could be 0 or it could be 1, but it's always in between, or 1 and 0 included. Therefore, your book says at the top of page 285, thus we see that the probability of a -2 or of a 7 1/3 is not possible, because all probabilities lie between 0 and 1 inclusive. So now we have some examples to help us to understand probability better. Okay, so the first example says we have a fair coin. That fair coin has been tossed 3 times, and it has come up head, head, and head. What is the probability that we will also get a head on that last toss? Okay, so the probability that the next toss is a head equals, may I have a drum roll? It's still going to be the same probability of getting a head on any individual toss. Remember, we're tossing a fair coin. So the toss, each time we toss that coin, you have a 50-50 chance. That's 1/2 probability that it's going to be a head. Therefore, the probability that the next one is a head is also 1/2, because this toss is not influenced by these 3 tosses. That's what we mean by independent events. Each toss of the coin is a separate and independent event. And each event does not affect the next event. Okay? Therefore, each event, each toss, has its own probability and is not influenced by what has happened before. Okay, so this is example 2, and it is another fun probability question. We have 6 green marbles and 8 red marbles in an urn. Okay, so they give us a situation. 1 marble was drawn and replaced. So somebody pulled it out, looked at it, put it back in. A second marble is drawn and replaced. Somebody pulled it out, looked at it, put it back in. Both of these marbles were red. What is the probability that there is a red on the third draw? Okay, now notice, the big deal is each of the previous draws were replaced into the urn. Remember that each draw from the urn is independent of the other draws if the situation doesn't change. Do we still have 6 greens and 8 reds in the urn? Yes, because the 2 marbles that were drawn out and replaced were both put back in. And we assume that the marbles are stirred up so that each draw is completely independent of the ones that are before it. Therefore, since we're looking to draw a red, and there are 8 red marbles in an urn that has 14 marbles altogether, then we have 18 over 14. If we simplify that, that would be 4/7. So 4/7 is the probability that we will draw a red the third time because the other 2 marbles were replaced and the draws are independent of each other. And isn't 4/7 in between 0 and 1 because 7/7 would be 1 and 0 would be 0. Okay, so 0/7 and 7/7 isn't 4/7 in between. Okay, this is example 3. We have a single die, and it's going to be rolled 3 times. It already has been rolled 3 times, and we got a 1 and a 4 and a 3 in that order. What is the probability that the next roll will be greater than a 2? Okay, in order to do this, we should look at the sample space of the die. Because remember, each roll is independent event. It does not affect, nor is it affected by what came before. So we have 1, 2, 3, 4, 5, 6 on our die. There's 6 sides, 1, 2, 3, 4, 5, 6. And how many of these faces are greater than 2? Well, 3, 4, 5, 6. So 4 of the faces out of 6 total faces would be 2/3 is the probability that we're going to roll something greater than 2. It's as easy as that. All right, so here we have another example, example 4. We have 2 dice rolled. What is the probability that the sum of the 2 rolls is 7, exactly 7? And what is the probability that the sum of the 2 rolls is greater than 8? Now, in order to do this problem, we need a little chart, which I'm not going to draw for you because they have done the little chart very nicely in your book. Now notice what your chart has. It has on this side down, it has 1, 2, 3, 4, 5, 6. And then across it has 1, 2, 3, 4, 5, 6. And then it makes a sum chart. 1 plus 1 is 2, 1 plus 2 is 3, and so forth. It has all of the sums. So now what we have to do is we have to look at the chart and say, how many of the sums are exactly 7? Okay, when you can see the sums, 1 plus 6, 7, 7, 7, 7, 7, 7. Okay, so as we go down, there are 6 ways to get a 7. Okay, so 6 ways would be, okay, I counted the 6 ways and put them on the board. 6 plus 1, 5 plus 2, 4 plus 3, 3 plus 4. Okay, remember this is the first dice and this is the second one. 3 plus 4, 2 plus 5, 1 plus 6. 1, 2, 3, 4, 5, 6 ways to get a 7. And notice, what is my total sample space here? Okay, so it's 6 ways across the top and 6 ways down the side. 6 times 6 is 36. We have a 36 size sample space. So if we have, for the first problem, 6 ways to get a 7, then when we're figuring out our probability that the sum is exactly a 7, we would take the 6 ways we could get a 7 divided by the 36 in the sample space. 6 divided by 36 is just 1/6 when we simplify it. So the probability that the sum is exactly a 7 is 1 out of 6. But now, what is the probability that the sum is greater than 8? So now we have to go back to our little chart here. Okay, now I made our chart a little bit larger. 6 plus 6 is 12. That's greater than 8. 6 plus 5 is 11. 6 plus 4 is 10. 6 plus 3 is 9. And that's the smallest we can go to be greater than 8. Okay, so our event that we're looking for is greater than 8. All right, so 9 is the lowest we can go. 5 and 4 is 9. 4 and 5 is 9. 3 and 6 is 9. So now everything up above this row is going to be less than or equal to 8. We want greater than 8, so we want 9 or more. This is going to be a 10, 11, 11, 10, and look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 outcomes that are greater than 8. So we would do this. 10 outcomes are greater than 8 out of, remember the whole chart has 36 outcomes. So 10 over 36, divide both of those by 2, and we get 5 over 18, and that's as far as we can divide it. So the A part of example 4 was 1/6 because that was the probability we roll exactly a 7 with the sum of the two dice. And the sum is greater than 8 would be 5 out of 18. It is fun and easy to figure out probabilities. Okay, so here we're talking about 70B, designated order. Does it matter if we specify the order? And the answer is yes. The probability of future outcomes of independent events happening in a designated order is the product of the probabilities of the individual outcomes. So if I am going to say, what is the probability that I toss a fair coin and I'm going to get a head and then a tail? 2 tosses, a head and then a tail. Well, the answer, according to this, is going to be the probability of a head, which is 1/2, times the probability of a tail, which is 1/2. I multiply them together and I get a 1/4 probability that it's going to happen in the order that I specified. So 1/4. Now let's look at a tree diagram to show you that. If we have 2 events, flipping the coin, okay, and we're looking for the probability of a head and then a tail. So here is the first flip, and we get a head or a tail. And then we have a second flip. And from the second flip, we get a head or a tail, a head or a tail. Okay, so by the time we get down here, we've got 1, 2, 3, 4 different paths that we could follow. So we've got 4 different ways to order it in a sample space. So we could come up with a head, which is head and then a head, or a head and then a tail. Then we could have a tail and then a head, or a tail and then a tail. Those are all the different ways that it could happen. Now, 4 different possibilities, but the one we're looking for is head and then a tail. There's only one head and then a tail, so we have a 1/4 probability that we're going to get a head and then a tail, which is much simpler to just multiply 1/2 times 1/2 and get 1/4, isn't it? Okay, so here we have the next example. We have a fair coin tossed 4 times. What is the probability we're going to get a head and then a head and then a tail and then a tail? So when we're looking at this, we can use our little model that we just learned our rule. So we're going to take 1/2 times 1/2 times 1/2 times 1/2, 1/2 times 1/2 times 1/2, and come out with 1/16. Okay, so 1/16 is the answer. Now we're going to do a little tree diagram. Okay, so the first flip was a head or a tail, and then a head, tail, and then a head, tail, head, tail, head, tail. Yes, hold on. Head, tail, head, tail, head, tail. And then the next one is a head, tail, 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 head, tail. Okay, so 2, 4, 6, 8, 10, 12, 14, 16 different ways it could happen. 16 different possible outcomes in our sample set. So if we were to label those 16 ways, we would have what? Head, 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 head. That would be one way. And then the next way would be head, 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 tail. And I'm not going to label all 16 ways. Okay, but hopefully you get the idea. But of those 16 ways that it could happen, how many of those ways have head, head, tail, tail? Okay, so that means we're going to have a head on the first throw, and then we're going to have a head on the second throw. So this is the path we want right there. But then the third throw has got a tail. Okay, so now we're following this. Okay, and then the last one is a tail. So it's this one. There's one path, head, head, tail, tail. One path out of all 16 possible paths that gives us what we want. So 1 out of 16 would be the probability of head, head, tail, tail. But isn't it faster to use the rule? We take the probability of a head, which is 1/2, times the probability of a head, which is 1/2, times the probability of a tail, and the probability of a tail, we multiply them all together and we get 1/16. It's much faster than doing our tree diagram. However, you should understand how to do a tree diagram so that if I ask you to do a tree diagram, it's no big deal. Just start out with more paper than I did. Okay, so on this one, example 6, we have a spinner. Okay, now you know a spinner. There's a little nail or something in the middle, and we spin it around. And it says the spinner is spun twice. What is the probability I will get a 4 the first time and a 3 the second time? Well, there's 1/4 out of 4 outcomes. So that would be 1/4. And there's 1/3 out of 4 outcomes. So that would be 1/4. And I multiply them together and I get 1/16 would be the probability that I would get exactly this order of items, that the events would happen in that order. So the probability of 4 and then a 3 would be exactly 1 out of 16. We could do a tree diagram with that too, but it's much faster to just multiply 1/4 times 1/4 and get 1/16. And here is your first practice problem. Practice problem A. We have a fair coin and it is tossed 3 times. What is the probability that it's going to be a head and then a head and then a head? I get a head each time. Well, we know the probability of a designated order is going to be the product of each individual probability. So the probability of head is 1/2 times the probability of a head is 1/2 times the probability of head is 1/2, and we have 1/8 of a probability that we're going to have head, head, head. Did you get it right? Okay, so here we have B, and I want you to do it on your own before you look at the answer. We have a single die rolled 3 times. The next roll, what is the probability that the next roll will be a number greater than 3? Remember, do the previous 3 rolls of a die affect the next roll at all? No, because the roll of a die, those are independent events. Each one stands alone. Okay, so we're really looking at the probability that any roll of the die is greater than the number 3. So remember, on a die we have 1, 2, 3, 4, 5, 6 faces. And of those, the numbers that are greater than 3 would be 4, 5, 6. So there are 3 that meet the requirement out of 6 in the total sample space. So the probability that the next roll will be greater than 3 would be 1/2. Okay, so 2 dice are rolled, which means, remember, when 2 dice are rolled, then I'm going to use my chart that has 1, 2, 3, 4, 5, 6 across the top and 1, 2, 3, 4, 5, 6 down the side. And 6 times 6 is 36. So there are 36 possible outcomes, right? So 36 is going to be in the denominator. And then, how many ways can I get a 6? Well, a 6 on 2 die, okay? So if I had my little chart here, I could do that. I could say, a 5 and a 1 would make a 6. Neither one could be a 6, right? 5 and 1. A 4 and a 2 could be a 6. A 3 and a 3 could be a 6. A 2 and a 4 could be a 6, and a 1 and a 5 could be a 6. But there's no 0 on a die, so I cannot use 6 at all on any one of them. So 1, 2, 3, 4, 5. There's 5 outcomes that would have a result of 6. Now, we'll go to my little handy-dandy chart in the book, and if you look very closely, you can see 1, 2, 3, 4, 5 ways to get a 6. Okay, so you could go look at the chart if you had the chart right there, or you could just figure it out the same way I did, knowing that there's 36 possibilities. Now, there's no way to simplify 5 over 36, so that would be our final answer for C. Okay, so this is practice problem D, and you've seen something like this before. We have 6 pinks and 7 blue marbles in an urn. So here it says, what is the probability that the next draw will be pink after 2 pink draws have been replaced? So they drew a pink and they put it back in the urn. They drew a second pink and they put it back in the urn. So what is the probability of the third pink? Well, remember that each draw, because it's being replaced back in the urn, is independent of any other previous draws. Okay, so when they do this, they really do, when you see a replacement, it's like a replace and a stir. Okay, so they're completely starting fresh again with each draw. So the 2 pinks that came before have no bearing at all on what's coming next. Therefore, we have 6 pinks out of 13 total balls in the urn. So 6 out of 13 will be the probability that we will draw. a pink. And this is your last practice problem before you get to go off and do your homework. So we have a spinner spun 3 times. And here's the picture of the spinner, a 4, 1, 3, 2. Each one only happens once. And we're supposed to find out what is the probability that I get a 2 the first time I spin, a 4 the second time I spin, and a 3 the third time I spin. So the probability of a 2 is 1 out of 4. The probability of a 4 is 1 out of 4. And the probability of a 3 is also 1 out of 4. 4 times 4 is 16 times 4 is 64. I have a probability of 1 over 64 for that to happen in that order. And we are done with lesson 70, which is all about probability and designated order. I hope you've enjoyed this lesson. I certainly have. This is Mrs. A, and may God bless your day.